everyone. We're here today to demonstrate the first part of the depth study that we're undertaking in Year 11 Chemistry. The first step of the process is such a dangerous part that we're actually going to be doing it in the fume cupboard, and so it's a teacher demonstration and students can't do it. So we have nitric acid here, which is a very dangerous substance, and also in the chemical reaction we're going to be producing nitrogen dioxide, which is a toxic substance, and that's why we've got the fume cupboard. The sound you can hear is from the fume cupboard, which will take away the nitrogen dioxide fumes. And obviously you can see another safety issue is what I'm wearing, gloves and apron to ensure in case there's spillage that it won't affect me. So we're starting off, we're actually going to do this experiment in two different conical flasks. So I'm moving over to where we're going to measure the 0.5 grams of copper. Got two conical flasks. So if you look here, we've got a thin strip of copper and we've molded it into the shape of the ball, and we've measured the 0.50 grams of it. And so we're going to place that into one of the conical flasks. We're making sure we tear the scales. Then we're going to place on two strips of metal. And we are getting very close to 0.50 grams, and there it is. And then we're going to place that into the second conical flask. I have conveniently already measured out we're doing approximately 4 to 5 mils of the 16 molar nitric acid. Even when I poured it in before, the fumes were coming out, but now we're going to pour it into each one. I've got a stopper here where we're going to place that on top, so we'll hopefully notice the brown nitrogen dioxide coming out. And you can already see that the reaction is taking place and the brown fumes are coming out. And I'm going to do that with the other one too. I'm going to give it a little bit of a swirl. At the moment, all the pieces of metal have not completely dissolved, so I'm giving it a bit of a swirl to speed up the rate of reaction. And now that it's very obvious that the brown fumes can be seen, I'm going to actually take the lid off just in case there's a build-up of pressure, which could be dangerous. And take it off both conical flasks. You might notice something about the colour of the solution too. And I'm hoping this fume cupboard will get rid of all that nitrous dioxide. And so we can have a better look at where the metal is. Maybe from the bottom. So I'll keep shaking it, stirring it. Perhaps you might want to think about how we would ensure that the reaction has gone to completion. One way would be looking at the pieces of metal to ensure that they have completely dissolved. You might like to think how else you would indicate it. At the moment, we are going to probably have to pause the experiment so that we will view it once all the reaction has completed. So it has just been suggested by my wonderful assistant here that we'll get a bit of white paper to place underneath, that we might be able to notice it a little bit better. Hopefully you have been thinking that another way that we would indicate if the reaction has gone to completion, there would be none of the nitrous oxide present. I think if you look carefully at that, I can't see any signs of the copper metal being left in that beaker, that conical flask. And in here, I think there's still just a little bit left there. So if we stir that a little bit more, then we think that the reaction is nearly gone to completion.